Hi everybody, this is Nafish. Today we are going to go over some of the very key functions in Python. So first of all, what are the differences between deep copy and shallow copy? And then very basics of interpolation and how to use this where function. So basically, this is these three items I'm going to go over. Okay, so let's get started. First of all, we have to import pandas as PD, and then let's create a data frame. Okay, so first run this line, and basically we need to create a data frame so that I can show you the difference between a deep copy and a shallow copy. Okay, so I have imported pandas as PD, and then let's create a data frame. Okay, so let's say name of the data frame is A, and you know we are going to call PD dot data frame, and then inside the data frame we have list of numbers, let's say 10, 20, 30, and 40, and we're going to call a column. Columns is, we have to give it a name, right? So let's say we have one column and the name of the column is numbers. Okay, so this is our data frame, and we're storing this in a variable called A. Okay, so let's run it and let's look into the data first. So A got four sets of numbers. Okay, so now we are going to copy this A and put it in a different variable called B. So B is nothing but copying A, so copy. Okay, so calling the copy function and put it in B. Okay, and then let's visualize B, and as we expected, the same numbers, right? So basically what this is doing is copying all these numbers, okay, 10, 20, 30, and 40, and putting it in a new variable in B. Okay, now this is called deep copy, and the copy usually, mostly we have seen. There is another type of copy which we call shallow copy, and let's say we have created another variable C, and we're going to um, copy the exact variable A, okay, and put it in C. So copy A dot copy, and then here we are mentioning deep is equals to false. So basically this is just a shallow copy, and what this is going to do, this is just going to refer to the memory addresses of this variable A. So basically this is just pointing the values of A. Okay, so if the one of the values of A gets changed, that's going to be reflected in this variable C. However, in case of B, this is, where deep is for true, by default, there we are just copying the numbers. Okay, there is no pointing out of the memory address. So let's say, let's see C, and you see like we have A, B, and C, everything is same, right? Now as I mentioned, how about if we change A? So let's say A dot ilock, and we're going to change the number at location 0. Okay, so calling the ilock function, and here what we're going to do, ilock, just calling the 0 index and then putting, let's say, 1000 there. Okay, run it. So now our A got changed, right? So the first element is 1000. Now let's see whether this change has reflected in B and C. So B, remember, B was a deep copy, so B, it should be same, right? But in C, where we are just pointing out the memory location of A, that should be changed, and you can see out here. So basically, why do we need this shallow copy, or how that can be used? Basically that is much faster. We just don't need to create, another variable. Rather, I mean, we can just point out the memory location and use the same memory location, right? So that's going to be efficient both in memory and time wise, right? So I think this example, if you try, you can just, you can try different ways and you can see how this is working. But remember, by default, um, when you do copy, that is the deep copy. So basically, we create a variable and that is totally independent of A. Okay. So if A gets changed, there is nothing gets reflected on B because they are different, right? But once you do the shallow copy, which is completely dependent on the variable A, and there, basically you are sharing the memory address, pointing out the same location, and if A gets changed, that will be reflected in C. Hopefully, I think the example will provide you enough information about what are the differences between shallow and deep copy. Okay, let's move into another thing. Um, Here, I'm just going to go over interpolation, and how can we use this interpolation to fill out the null values. Okay, so just copying the same data frame A. Okay, is going to use it in a different example. So let's say we have numbers, let's say 100, 200, and this number is missing. So let's say um, np dot nan. So basically this is saying, like, this, that value is missing, and then we have another value that is 400. Okay, so this is our data set. And oh, okay, I think we have to import numpy here. Import numpy where the nan is located, that function. So import numpy as np. Okay, and then run the cell. So now we have the a data frame. So you can see, like, this value is missing, right, at index 2. So we can just, in order to run the data set, sometimes we do interpolation. So interpolation is nothing but, fill in these values with some methods. It can be linear, it can be a polynomial. I will show both, but this is a deep topic. You can just go over it, or I can just go over it in a later time. But here I will just show, like, how can we fill in these NaN values, right? So what you can do is a dot interpolate. Just press tab, and this is going to pop up, and by default that is linear. Okay, so if you just hit run here, you see the value is kind of 300. It's just interpolating the value from the other values, right? This could be, we can use another method to fill in this non-value. And here, in case of linear interpolation, which was by default, we can just say um, method is equals to polynomial um, meal, and then let's say specify the order is equals to, let's say, 2. Okay, and then run it. I hope the spelling is right. Okay, so here you see we can use a different method as well. Now, since the data is linear, you can see our data. If you just look at the data, from a high level, you can say, like, that's kind of linear data, and that's why linear interpolation is working fine. But if the data is kind of, there are non-linearity or non-linear behavior in the data, you can try different method, like the polynomial method, with different type of order. Okay, but this is just the basic, how to fill out the NaN values. Okay. Now, other thing I would like to show, that is the use of where. Okay, so let's say we have the same data set. Okay, let's just going to change a. Um, a is, remember, we had a nan value, right? So let's change that number. So a dot alloc, and since even if we have done the interpolation there, it's not keeping the value because we have to write in place is true. Okay. So let's do the interpolation again, just to show you. So run A, and there's the value. So now do the interpolation, and here just write in place. In place is true. So that's going to keep the value. Okay. So replace the A with the interpolated value. So run it, and you see you are going to get these values. Okay. Now I wanted to show how to use where. Okay. So let's say A dot where. And the use of where is, like, we have to put a condition first, and let's put a condition first and then the value. So this is how the where function will work. So let's say we want to have a value, a is greater than, let's say, 100. Okay, so if this is true, the values will be kept, and since we did not mention any value to replace here, usually we do it like after the condition, this will be by default nan. Okay, so let's say a dot where. Okay, here it is. So basically, whenever that is true, it's keeping the value. So whenever it's greater than 100, this condition satisfied. 200, 300, and 400 are kept. But since 100 is not greater than 100, it just replaced by nan. So we have to have a condition which is there, and then a value. Since the no value is there, it's just providing nan. Okay, I'm just going to give you another example where we have a value. Okay, so let's say here we want everything above 200. Okay, and if it is equal or below 200, is going to be replaced by a value 5. Okay, so let's run it, and now you see when the conditions are met, we're just keeping this 300 and 400, but when that is false, we're just replacing the value with 5. Okay, we can go and use a different condition. So for example, um, let's say we want to create a condition, right? So let's say c is equals to um, a, and then let's say 20 is equals to 0. So basically the values of a, if there is no reminder, s- that is going to be true. This is the condition. Okay, so we're going to, so basically all the values, if you look into a, those are divisible by 20, and there shouldn't be any reminder. So all the values uh, should be kept as it is. Okay, if we use this condition. So let's say c, so this is our condition which is mentioned there, and if the condition is not satisfied, will be replaced by 5. But we are expecting, everything is divisible by 20. So, oh, this line I didn't run, so I have to run it and then run it. So you see all the values are kept as it is, but we can use this, change this number. Let's say we put 30. Okay, so you can see like clearly 100 is not. So if you divide 100 by 30, there will be some reminder. Okay, it will not be 0. Okay, so definitely 400 is not divisible by 30. There will be some reminder. Okay, so let's run it and then look into the data. You see all three values got replaced by 5, because in those cases the conditions were not met. Okay, I hope you enjoyed the lesson. Thanks a lot. Take care.